So here we are. We're going to talk about the PHRC webinar, the first webinar of 2025, Decked Out, a dive into the updated 2021 IRC residential deck code provisions. Again, Pam had mentioned that this is accredited or approved through AIA. So we will jump right past this and look at the description that talks about, join us for an overview of the updated 2021 International Code, Residential Code or IRC deck provisions, right? So we're going to kind of work through this whole process like you were going to design a deck. If you have tuned in previous years or have been to one of our speaking engagements where I, delivered this deck program, it typically started off with looking at, the first half, a bunch of failures, deck failures, and then we talked about specific code provisions that kind of address, those failures and hopefully preventing those failures from happening again. This program here, this webinar here is going to pivot away from that a little bit, although we will look at a couple failures at the beginning, but I'm not going to spend a lot of time on it, just one slide with a couple pictures. What we're going to do today is we're going to be in the driver's seat of designing a deck, right? So we're going to come up with a size and we're going to work through the provisions in a way that you would if you were going to design a deck, right? If you're sitting, whether you're a designer, if you're sitting at your desk, you're like, okay, this customer wants this size deck. Where do I start? How do I work through these code provisions to come up with the materials needed to then build this deck? That's kind of the approach that we're going to take here today. So we're going to it's a study here, but we're going to look at a couple of pictures of failures and what happened there. We're going to understand the provisions of, chapter 5 out of the 2021 IRC, right? You may be saying, well, Chris, we're not in the 2021 IRC, and that's true. We're not yet. But I have a couple slides that kind of address why we're going to talk about the 2021. We're going to identify new and revised portions of the code in regard to residential decks, and then we're going to review residential deck guard railing test results. Not really the testing that came out of Virginia Tech, but there is that great testing that did come out. But we're going to look at the new provisions in the 2021 that are kind of driven by those test results that I'm not going to get into the testing, but we're going to talk about those provisions that are now there and a good way to hopefully achieve what's being asked for. So as I said, we're going to be talking about the provisions in the 2021, and there is going to be a new base code come the middle of this year. So we're going to be pivoting from what's being shown here, the 2018 IRC, and pivoting into the 2021 IRC provisions. You can't forget, right? We have that base code, but we also have statutory amendments, which don't really get touched on here. They will not be touched on here today. And then there's also RAC amendments. The Section 507 of the IRC 2021 IRC was adopted without any modifications. So these RAC amendments also don't apply. But if you are curious as to what those amendments are, I would check that out off of the RAC's website. These changes are anticipated to go into effect on July 13th, 2025. So this year, midway through, the new base code will go into effect. There is a phase-in period for that. If you are at all curious on how that adoption process happened or what that phase-in period looks like, I would encourage you to hop on our YouTube channel. Again, as Pam had mentioned, you can search that at PHRC Penn State and search for the video titled PA-UCC Residential Code Update Part 1. The first half of that really goes through the update process or the new code adoption process, this date of implementation, the phase-in period, and some additional things that you may want to know or find interesting. I would encourage you to check out that video. But first thing we're going to do here is look at a couple failures. If any of you are on social media and you may have come across a Facebook page titled "The Worst Decks / Construction," that's where these pictures came from. You can find that with the link here at the bottom of the screen. If you're looking for some really interesting photos, I would check it out. Don't do it now. Wait till after 2 o'clock today to do that. We'll get through this presentation, and then you can go ahead and check that out. But we're going to look at deck loading. What's the loading parameters or where do we go to find which loading parameter is takes priority within the Commonwealth of Pennsylvania. As you can see in this picture here, they might not have looked at those loading parameters. The second thing here is we're going to look at joist design and in installation, a little bit of the installation portion of it. I don't think that this is code compliant. If anybody is a code official here and they want to chime in the chat, I don't think it's code compliant anyway. I can't imagine. But again, we're going to look at how we can design the joist to comply through the 2021 IRC. We're going to look at the connection of deck beams to the deck posts and how that should occur. And then we're going to look at the design of deck beams, period, right? How do we choose the correct deck beam for what we're looking to achieve at the end, right? There's so many options out there. Number of plies, number of the connection of those plies and how it relates to the connection of that beam to the post itself. And then here, I think we have some lateral issues going on. We'll look at, how those posts also should be restrained laterally or resist lateral loading, and how that can be achieved through connections and also embedment into the soil. So again, these photos here might be a little bit extreme, but it has to be real life if they took pictures of it, right? So pretty crazy. Jumping into, so here we go, right? We're gonna jump right into the deck design process. These are the bullet points that I want to kind of work through here today. Our deck design is going to be 20 feet wide, 16 feet deep, 6 feet above grade. And you can see here that the first thing here is design. What are our design guidelines? So this is this is what we're going to start out with here today. And hopefully by the end of today's presentation, we have this filled in really nicely that is almost to the point where you could be able to submit it for permit. There might be some notes, things of that nature that might be needed to be added to it. However, we're going to take this layout, right, and we're going to fill in the missing blanks of what's required for the design and construction of a deck of this size. So looking right into it, as most of you probably already know, the deck design or the deck provisions come out of chapter 5, section 507. This was brought in, I believe, back in 2015. It's fun to look back through the iterations of the deck provisions in previous code cycles. Back in 2009, there really wasn't a whole lot listed. I don't think there was not a section specifically for decks. You had to jump throughout that code book to find, how do we design the joist? How do we design the beam? How do we design the footings? And then in 2015, they created chapter or section 507 for residential decks, and they did a really good job at beginning to put in a prescriptive pathway to design decks, right? There was always some missing pieces to it, and I would say 2018 they began to introduce the new sections. 2018 they introduced, I believe that was the provision where they introduced the prescriptive design for footings for decks, which was a big step. Before that, you had to look through different loading scenarios to try to find out what that might be. And then here in 2021, we'll jump a couple steps here. Now we have our new provisions for the design of guardrails that was always missing. Again, it could probably be a little bit better as far as providing a clear path, but hopefully I can fill in some of those blanks here today. So wood frame decks shall be in accordance with this section. Decks shall be designed for a live load required in section 301.5 or the ground snow load indicated in table 301.2, whichever is greater. This provision here is new to the 2021. Previously, they kind of just said, you had to meet the loading provisions, the loading cases. Now in 507.1, they're really calling out that you have two options, live load requirement or ground snow load. So we'll jump to table, this is table 301.5, minimum uniformly distributed loads, and we are looking here at balconies and decks, right? So let me get my cursor, if my highlighter, doesn't want to show up here. But we have balconies and decks that have a uniform load of 40 pounds per square foot. That's our starting requirement, but it also says that you have to look at the ground snow load. This is the ground snow load map coming out of the 21 IRC. I'm sorry, it's a little fuzzy. Hopefully it comes across a little bit better for you guys. But as you can see here, even looking in Pennsylvania, there are several scenarios that range from 20 pounds per square foot ground snow load up to 35 pounds per square foot ground snow load. But you also have these areas that are called out with CS. That's case study, right? So you have to reach out to those local municipalities to find out what the ground snow load is for those specific areas. Um, so you're going to have to look at your region and figure out which one is greater, either the 40 pounds per square foot live load, which is listed, uniform load, which is listed here, or you're going to have to look at this ground snow load map. And if you're above 40, then this, based on your specific area, you will then have to use that as your governing factor. But for today's example, we are going to run with the 40 pounds per square foot for residential deck uniform loading as our precedent or our max loading for design. Next, now that we have our loading figured out, that'll help us in all of our tables moving forward. Jumping into deck joist design. This is section 507.6. We want to figure out, what size and spacing of joist should we be using for our 20-foot wide by 16-foot deep deck. And this section states that the maximum allowable span for wood deck joist, as shown in these figures, shall be in accordance with such table. But then it goes on to say here that the maximum joist spacing shall be limited by the decking material in accordance with table 507.7. So if I'm thinking to myself that a typical design is 16 inches, I need to make sure that I can span 16 inches with the decking that I want to use. So before I can jump to these tables, talking about maximum spans, I need to make sure that my initial design for decking works, because that would be our governing factor here. So for that, we will jump to section 507.7, which is decking. And this states that the maximum allowable spacing for joists supporting wood decking, excluding stairways, shall be in accordance with table 507.7. It then goes on to say here that if you're using something other than wood decking, then you need to use the manufacturer's installation instructions, and they should be attached or installed using such fasteners. But we want to jump to 507, the table 507.7, which is the maximum joist spacing for wood decking. My design what I'd like to use based on my budget is I want to use the 5/4 by 6-inch decking, right? So that's the 1 1/4 inch thick wood, as shown over here for our decking material and size. It is going to be multi-span. It's going to span over top of our deck joist. And this does clearly say that I'm allowed to use that material at 16 inches on center. And this is installed perpendicular to the joist. I do not intend on designing or installing the decking at a diagonal or 45 to the joist. I do intend on installing it 16 inches perpendicular, or perpendicular to the 16-inch on center joists. So starting to fill in our design or our layout here is our 1 1/4 by 6-inch wood decking running this direction, obviously, and that will be running perpendicular to our designed 16-inch on center deck joist. Next, our maximum allowable span, this jumps back to 507.6, jumping back to the deck joist provision. The first half of this, maximum allowable spans for the deck joist as shown in figure 507.6 and in accordance with table 507.6. So what we have here is showing a couple different things here. One thing that I want to point out is it's clearly showing that whenever we're referring to deck or joist spans, it's referring to center of bearing to center of bearing. So that's a good thing to keep in mind moving forward here. That also carries true with beam spans. Another thing I want to point out here is that whenever we have a cantilever, it says for cantilever joist blocking or other lateral restraint is required over top of that beam, right? We want to prevent any sort of rotation over top of a bearing surface. These top two, the one here on the left hand is showing, as I just mentioned, a cantilever. The one on the right here is showing a flush beam. So our post is right here, and then we have a beam installed directly over top of the post with a zero cantilever flush beam, so the joists are hanging into joist hangers on both sides. Down here at the bottom, what I want to point out here is the title, and it says joist on freestanding decks and joist with a flush beam and with drop beam. I want to throw a little bit of caution here to the terminology being used here for these two bottom figures. The calling them out as freestanding decks does not necessarily 100% mesh with a definition or exceptions later on that relate to what a freestanding deck truly is. So what I typically call this scenario here that you're seeing across the bottom is a non-ledger deck. So the two at the top I call ledger decks because they have a ledger board attaching to the primary structure. The ones on the bottom are non-ledger deck, which means you have a beam at both sides of this deck. So moving on into the maximum deck joist spans, we now know what that span actually is, center of bearing to center of bearing. We know what our spacing is based on the type of decking that we're using. So our allowable joist span, our joist spacing is 16 inches as being shown here. And we're planning on using 2x10 joist. That's calling out for a 14-foot joist span. As you can remember, thinking back to the layout that I'm basing this all on, it was calling out for a 20-foot wide by 16-foot deep deck. That is 2 feet greater than 14 feet. So let's jump over here to our next group of dimensions, and that's with our maximum cantilever, right? So this is now saying that with a joist span of 14 feet with a 2x10, we can have, right here's our joist span, a maximum cantilever of 3'4". Well, that exceeds our 16 feet. So this will meet the design intent of our deck. A couple provisions here that, for the sake of time, I'm not going to get into. However, we do have some additional deck webinars and information on our website that you can jump back to that does talk a little bit more in depth about these two installation processes of deck joist. And section 507.6.1 says that deck joist, it goes over the deck joist bearing requirements, whether it's over top of metal or concrete, or if it's going over top of wood. And then 507.6.2 talks about the requirement for deck joist lateral restraints, which can be achieved in most applications by the installation of joist hangers and rim joist at the other side. So looking at this layout, we now have our decking, and now we have 2x10 joist at 16 inches on center, and we know that at some place this beam has to be pulled in because we are going to have a cantilever. All of our design requirements or presumptions had 14 feet span, with the remaining being a cantilever. So we also have our location of our deck beam. Again, deck joist, we're going with looking at two 2x10s at 16 inches on center. So now transitioning into the deck beam portion of this design, this comes out of section 507.5, deck beams. And what that section says, it says the maximum allowable span for wood deck beams as shown in figure 507.5 shall be in accordance with tables 507.5 parenthesis 1 through 4. Beam plies shall be fastened together with these fasteners. And then it goes on to say that beams shall be permitted to cantilever at each end up to 1/4 the actual beam span. Okay, so this gives us a couple different applications or a couple different thought processes on how we might be able to set up our post configurations for this beam as well. This is figure 507.5. This is the typical deck beam span figure, similar to what we found in the typical deck joist figure, that the span of these products or these members do continue to go center to center of the bearing points. So here we have our beam span and then our optional cantilever. What it said in the provision is that our cantilever can be up to 1/4 what this beam span actually is. So let's keep that in mind. What we're showing here in both of these sections, or both of these images or figures, is the one on the left is for a dropped beam, right? So we have this beam has the joist ending on top of it or extending beyond with a cantilever. And then over here on the right-hand side is an example of what a flush beam may look like. Again, these joists are hanging into the side of the beam without any sort of cantilever. So here we are looking at table 507.5 parenthesis 1. This parenthesis 1 has to do, the different tables have to do with different loading cases, right? So we are working with 40 pounds per square foot live load. That was our design criteria that we found number 1 in this process. So we will jump to 507.5 parenthesis 1. And we want to look at what are our options for beam spans and the number of posts that we might be able to have in there. Remember, we're 20 feet wide here, right? So if we're looking at our effective, right here, effective joist span length, and we were at 14 feet. Now, there's a footnote that we're going to look at here in a little bit, but we were at 14 feet, right? That was our span. And let's try to limit, the intent here is to limit the number of posts required. So if we did 14 feet and we jumped up to a double 2x12 as opposed to a double 2x10 that would match the joist, we are able to have a beam span length of 8 feet, right? So 8 feet plus 8 feet is 16 feet, plus 1/4 of those spans, which would be 2 feet. So if we add a 2-foot cantilever to either side, that gives us a grand total of 20 feet, right? 8 feet, 8 feet, and then 2 feet cantilever each side adds up to 20 feet. So number 1 here, our initial concept is to run with a maximum beam span length of 8 feet. However, looking a little bit deeper into this, a deck with a ground snow load of 40 pounds per square foot is designed using 2 plies of southern yellow pine double 2x10. Joist span is 14 feet, therefore, and there's a 24-inch cantilever at each side. So looking at this next table, it has C and J. The C stands for cantilever, and J stands for joist. And a little note here states that without footnote J, this limit is of 8 feet. So again, we're looking at double 2x12. Our limit is 8 feet. And what we're seeing down here is for calculation of the effective joist span, the actual span, the actual joist span length shall be multiplied by the joist span factor in accordance with table 507.5 parenthesis 5. This is new to the 2021 IRC. So let's jump into, this is table 507.5 parenthesis 5, and this goes into the joist span factors for calculating the effective joist span. So what we're doing here is over on the left-hand side, this is the calculation that we have to do that takes the cantilever and divides it by the joist span. So what we'll be doing is taking 2 divided by 14 gives you a factor, a span factor of 0.143, right? So 0.143, there's, as you can see here, there's no allowance in the footnote for interpolation happening with these numbers. So we would have to jump to the greater, or round it to the greater factor, which is a 0.167 or 90%. So applying this adjustment factor to from table 507, that should be 507.5 parenthesis 5, where we took the cantilever and divided it by the joist span. So 2 divided by 14 gives you a factor adjustment of 0.143. So what exactly does that mean? That's what we want to figure out. And footnotes in table 507.5 parenthesis 5 does not call out for the allowance of interpolation. So we will round it to the 0.167 or 90% joist span factor. An effective joist span can be calculated by taking 90% times 14 or 0.90 times 14. So our effective joist span is 12 feet 6 inches. The maximum beam span can be determined from table 507.5 parenthesis 1 for a 14-foot effective span of 8 feet for a joist span, or by interpolating that table 507.5 parenthesis 1 footnote A for an adjustment joist span of 12 foot 6 per footnote A. It gives you a maximum span of 8 foot 5. So you might be thinking, Chris, what does all of that mean, right? Let me jump back to this table here. If you initially wanted to run into this without any sort of joist span framing or length, joist span factor, you could simply say we are a 14-foot joist span and then go with 8 feet maximum beam span for that indication. However, now the 2021 IRC allows for a joist span factor that can give you a new effective joist span length. And taking that into consideration, that does change this 14 feet of effective joist span from 14 feet down to 12 foot 6. So that puts us in between 8 foot 7 and 8 foot 4. Running the calculations, that gives you a maximum joist span of 8 foot 5. So that's a whole lot of numbers coming into play here. There's some calculations that have to be taken into consideration. But what this now allows for is you can take what is typically or what is initially set as your joist span, run a factor against it, and that does give you the capability of increasing your beam span running forward. So in our design, even though 8 foot does work, we actually have the flexibility of having a joist, or I'm sorry, a beam span anywhere from 8 feet, which is our most conservative adjustment, all the way up to 8 foot 5, which is our adjusted joists or our adjusted beam span length. So hopefully that came across in a way that makes sense. Working through this, there are some examples provided in the significant change book. If you come across this in the design process and you want help working through that, feel free to reach out to me here at the PHRC, and I'd be more than happy to work through that process individually with you, because there's a lot of jumping around from table to table, from scenario to scenario to fine tune that effective beam span length. Okay. Moving on into deck beam bearing, it says the ends of the beams shall have not less than 1.5 inch bearing on wood or metal, and then 3 inches of bearing on concrete masonry for the entire width of the beam. One thing that I continue to want to point out, this provision did not change, but it's always extremely important for me to want to point this out, that says where multiple span beams bear on intermediate posts, each ply must have full bearing on the post with accordance with figures 507.5.1 parenthesis 1 and parenthesis 2. And that's what this looks like, right? So what they don't want to happen, and if you have, again, if you've attended any of my previous deliveries of deck presentations, one of the first failure picture that I show is senior skip week, I believe 2015, where it's a bunch of students on a deck, and that deck is failing in between posts. And the reason it's failing in between posts is because these splice points happened in between posts. That's why the code made this modification or included this provision a couple iterations back, requiring for whenever you have a beam splice, it must occur over top of a bearing scenario. Couple different ways this can be achieved. This is showing two of them where you have an approved post cap. A lot of times it's a proprietary product. And then you have over here on the right-hand side a notch out of that post. It can be further shown here in this figure. This is right out of the IRC as well, figure 507.5.1 parenthesis 2, where it talks about notching of that beam to accommodate the transfer of loading from that beam to the post in a way that the fasteners are not carrying that load, right? So over on the left-hand side, you have a 4x4 where you have a minimum 2 inches of that post remaining behind it. Therefore, that only allows for a single ply beam. I don't know how often you're going to see that, right? More common you're going to see over here on the right-hand side, which is a 2-ply beam with a notching of a 6x6 to accommodate that. Deck beam connections at the supports. Again, this also did not change. However, I do still find this extremely important to show. Deck beams shall be attached to the supports in a manner capable of transferring vertical loads and resisting horizontal displacement. It's extremely important to understand that. That means that all of the fasteners that are chosen have to be able to transfer both vertical and horizontal loading. In that connection, right? If you're attaching a beam to the outside of a post, that is not allowed prescriptively through the code provisions, right? Where you're sandwiching that beam or you're sandwiching that post in between both plies of that beam. That means that those fasteners are then carrying the vertical loads of that deck, and those fasteners are just not designed to carry that much in shear loading. So again, it's important to know that. But then looking down here at the, we'll call it the salmon color. It's not necessarily red, but it says that bolts shall have washers under the head and the nut. The question comes up all the time. Can I use carriage bolts in the construction of a deck? And it's always been my interpretation of this provision that leads me to say that the answer is no. You're not allowed to use carriage bolts for the construction of a deck because it says that bolts shall have washers under the head and the nut. And many folks have said, well, you can get washers for the carriage bolt that is, instead of a circular interior of that washer, it's square so that it allows you to slide it over top of that part of the carriage bolt. But when doing that, it's now flat and it doesn't allow you to put the proper torque on that bolt to ensure that it's tight. So it's always been to avoid conflict. It's always been my interpretation to say no, that carriage bolts cannot be used in the construction of a deck. However, you know, the chat pod's there, and I'm always happy to hear what others have to say. So I like it. A lot of people are agreeing with me. Thank you. Jumping on, so now we can start again filling in additional aspects or additional pieces of our deck design. And now we have, again, 5-quarter decking, 2x10 joist, 16 inches on center. We now can call out specifically that our beam is going to be a double 2x12 beam with beam spacing or beam spans of 8 feet, and you're allowed to cantilever that up to 1/4 the span. So now we have 2-foot cantilevers, all adding up to 20 feet. So again, starting to fill this in, double 2x12 with 8-foot spacings and a 24-inch cantilever. Okay, jumping into deck footings. Looking at the first portion here, and this is, you know, when I had mentioned earlier on for freestanding decks, this does not apply directly to what we are looking at with the figures earlier on in relationship to the joist spans. But deck footing says that decks shall be supported on concrete footings or other approved structural systems designed to accommodate all loads in accordance with Section 301. Deck footings shall be sized to carry the imposed loads of the deck structure to the ground as shown in 507.3. I'm going to spend just a couple seconds on these exceptions. and it says that footings shall not be required for freestanding decks consisting of joists directly supported on grade over the entire length. Number two, footings shall not be required for freestanding decks that meet all of the following criteria. And here we have, the location of bearing points, a size limitation, and a height limitation. This freestanding deck does not, again, the terminology does not correlate to what we saw earlier on. Matt Hunter made a really good point in the comments here that freestanding decks earlier on, as prescribed by the code there, simply mean that all vertical loads are taken into consideration by beams, and then all lateral loading is taken into consideration with the attachment to the primary structure. I remember having a quick conversation with it was either Mike Moglia or somebody from the DCEC or the manufactured home design folks that state that some manufactured homes have a sticker on them that say that no additional vertical loads can be imposed on the unit. However, they do have some that allow for the attachment to help with lateral loading, right? So in those situations, you could potentially use the previous freestanding deck design where you have two posts and beams for carrying vertical loads, and then all of your lateral loading will be taken in consideration by the primary structure. Another thing where you could use that is where you have some sort of veneer that you cannot attach a ledger board to carry vertical loading. Maybe it's some sort of masonry veneer. However, you can go through that masonry veneer to withstand lateral loading, but you can't carry vertical loading. They're the scenarios that can be used there. This, however, is significantly different, where it talks about that not having or not requiring the need for footings to be below grade, so on and so forth. If you want to know more about this information here, reach out to me or check out our recorded previous. I believe it was a comprehensive deck design from footings to guards webinar, where I think I go into a little bit greater depth on this section here. But I'm gonna move on. Here are the figure 507.3 that talks about the deck to footing design. This did not change, right? This has changed over the past couple iterations of the code. However, transitioning from 18 to 21 really didn't change all that much. It does go on to say that the minimum size of the concrete footing shall be in accordance with 507.3.1 based on tributary area and allowing for soil bearing capacity. So if you are not 100% sure what tributary area actually is, this here comes out of the 2021 IRC commentary, and it does a really good job. It does a much better job in this commentary than a previous figure did. This does not show an incorrect design. This tributary area, the one that we're most concerned about, is area 5 and 6, because that's going to carry the most load. And if we want to be uniform in our footing design, meaning that we're going to design to the worst case and apply that to all the footings, that's the post and footing that we're going to look at. So looking at our design, we are going to choose the center post, and then our tributary area left to right is going to be midway from this post to each adjacent post. So that's 4 feet on either side, gives us a total width of 8 feet. And then we're looking at the half of the joist span, which is 7 feet, right? 14 feet total. Half of that's 7. And then we also have to include the cantilever, which is an additional 2 feet. So 9 feet times 8 feet, which gives us our tributary area of a grand total of 72 square feet. Here is table 507.3.1, which is the minimum footing size for decks. We're going to assume our soil bearing capacity is 2,000 PSF. So we're going to jump right to the middle of this table. And I also want to do a square footing. That's just my choice, and that's what I chose. So I'm going to go a square footing. So each side of the square footing, and we are 72 square foot of tributary area. We have for 40 pounds per square foot live load, we have a jump from 60 square feet tributary area to 80 square feet of tributary area. You are allowed to have an interpolation is permitted for this. So we are somewhere in between 15, a 15 by 15 and a 16 by 16. We're just over halfway. we're looking at a 16 by 16, but if you actually run the calculations, it's 16 1/4 inches by 16 1/4 inches. That is going to be our footing design, 16 1/4 by 16 1/4 by 6 inches deep. Again, that is coming based on the tributary area for a soil bearing capacity of 2000 PSF and running an interpolation between 60 square feet and 80 square feet. That comes to our actual dimension for our footing. Deck footings shall be placed not less than 12 inches below the undisturbed ground surface. That comes out of 507.3.2 minimum depth, but it does go on to say if you are in an area that needs frost protection, then you have to follow the provisions out of 507.3.3 for frost protection that says where decks are attached to a frost protected structure. In Pennsylvania, if you were outside today, you'll understand that you need frost protection. The deck footings shall be protected from frost by one or more of the following methods. Number one is extend below the frost line as specified in 301.2. Number two is erected on solid rock. And number three is other approved methods of frost protection. So we want to quickly jump to table 301.2, the climactic and geographic design criteria, where we have an empty slot here to add frost line depth, but we have a footnote. That footnote B simply says that where the frost line depth requires deeper footings than indicated in figure 403.1, which it does, the frost line depth strength required for weathering shall govern. The jurisdiction shall fill in the frost line depth column with the minimum depth of footing below finish grade. So what that means is that there's a lot of maps in the IRC. However, you will not find a map that defines what your frost line depth is for your given area. The only way you can get this is reaching out to the jurisdiction having authority over this project and ask them for what the frost depth is in your specific area. I have tried to track down this whole background on how we got to where we are for this, and it's very difficult. There's no defined pathway other than this is what the code direction is, and that's just what we have to follow, and we have to, take what that jurisdiction of authority has for those particular areas in regard to the frost line depth. So again, filling in another aspect of our deck design, and that is our 16 1/4 inch by 16 1/4 inch by 6 inch concrete footing that is typical across all footings in our deck. Below frost line, they have to be, that footing has to be below frost line, and that is defined by the local jurisdiction. For me, it's in our design here, it's 36 inches. So again, working through the process, check off everything above footings, and footings is, as I just defined, 16 1/4 by 16 1/4 by 6 inch deck footing. Moving on into the deck post, and this says that in section 507.4, we now want to, so we have, again, jumping back to this, we know what our decking is, we know what our joists are, we know what our beam is. We're slowly working our way down to the ground. We skipped right over posts, right? But we had to get some additional information first, and we have our footings designed. So now we need to connect our structure above grade to our structure below grade, and the way to do that is through our posts, right? So 507.4 deck post states that for single level decks, wood post size shall be in accordance with table 507.4. So jumping to that table, we are, remember earlier on, we said that we are 6 feet above grade. So we have a tributary area of 72 square feet. So we're in between 60 square feet and 80 square feet, but that doesn't matter. We want to install 6x6s, and we can absolutely do so with much room to spare because we are, again, 6 feet above grade, and we are allowed to have a maximum post height of 14 feet for 6x6s with a tributary area of 72 square feet. We are good to go. And even heck, if you're looking at 6x6s, you are good at 14 feet all the way up to 160 square feet of tributary area. So again, this table, if someone is looking to install 4x4s or 4x6s, whatever the case may be, this may come into play a little bit more. However, in our scenario here, looking through our design intent, we are good to go. That must bear additional notes for post and connections. Again, if you look at some of our other recorded sessions, we go into a little bit greater detail on specific other things. This being one of them, you can look at how do we make that connection from the post to that concrete footing, and resist lateral movement. It must be embedded, 12 inches in grade, things of that nature. So the last thing well, before we get to exterior guards, other design features, we're going to use a 2x10 ledger board that pairs up perfect with our 2x10 joists. And for our lateral restraints, there are two options. There's the option of requiring two 1,500-pound hold downs or four 750-pound hold downs. The four 750-pound hold downs are less invasive to the primary structure. Therefore, I'm going to choose using those. Again, if you want more information on how to design a ledger board or how to look at those lateral load restraints, reach out to me. I will put my email in the chat here a little bit later on, or you can find it on our website. But lastly, we're going to talk about deck guards. As I had mentioned earlier on, this was one of the last holdouts for a holistic deck design out of the IRC, and it is now added into the provisions. So we can find this all in section 507.10. Exterior guards, again, as listed here, it's all new to the 2021 IRC. And this section states that guards shall be constructed to meet the requirements of section 301.5 and 312 and this section. So really quick, looking at 301.5, this goes back to our loading table that we got our 40 pounds per square foot of uniform load for our deck design. We now jump back to that same exact table and we're looking at guards, guard infill components, and handrail. And it says that we have to have a 200-pound concentrated load for guards and a 200-pound concentrated load for handrails. Now, I do want to say that this did change. Previously, it said for guards that the guard had to withstand the 200 pounds at the top in any direction, okay? But now I want to point you to the new footnote here. It's changed slightly, right? So if we're talking about the top of our deck, right? This is not a handrail. This is a guard, and it says that where the top of a guard system is not required to serve as a handrail, the single concentrated load shall be applied at any point along the top in the vertical downward direction and in the horizontal direction away from the walking surface. So if you remember back in 2018, it said it must be applied at the top in any direction. The code changed that a little bit for guards that says that it must be away from the walking surface. It doesn't say in any direction. Just wanted to point that out. That can help with how we designed those attachment procedures for those railing posts. Next here is where the top of the guard is also serving handrail. A single concentrated load shall be applied in any direction at the top point. And again, concentrated loads shall not be applied concurrently. So if it's a handrail, it has to be applied in any direction because it's a handrail, not just a guard keeping you from falling out. So looking at the different portions in section 312, again, remember it says 301.5, which is the load that must be distributed, and 312. I'm not going to get into these. These have not changed. These have been around for several iterations of the code. 312.1.1 is where they're required. So where walking surface is more than 30 inches to the floor or below grade, you must have a guard. The height of those guards, as per section 312.2, says that the guard shall not be less than 36 inches in height. And our opening limitations per section 312.3 says that it shall not, we're talking about the infill portions, shall not allow for the passage of a sphere 4 inches in diameter. Now, I want to get to the points that are new in the 2021 IRC, starting here at 507.10.1, which is the supporting of the guards. Where guards are supported on the deck framing, a guard load shall be transferred to the deck framing with a continuous load path to the deck joist, right? We want to take that loading from the guardrail to the deck joist, and it must be transferred in a way that can transfer the entire load. Real quick, I know we're running rate just about on time here, but this rate here, again, if you've attended any of our code or our deck programs previously, a lot of them talked about the Virginia Tech testing for these guardrails, and they did an excellent job at looking at how that load was transferred to the joist, and that's where a lot of this information did come from uh, through that testing procedure and then bringing it into the requirement for a code. This now goes on to say where guards, this is again 507.10.1.1, where guards are connected to the interior or exterior side of a deck, joist, or beam, the joist or beam shall be connected to the adjacent joist to prevent rotation of the joist or beam. Connections relying on fasteners and end grain withdrawal are not permitted. There's a lot to unpack there, and I hope that these figures right here can help solidify or work through that with you. This is the figure over here on the left-hand side. Again, this comes out of the commentary that tries to do a good job at explaining what that provision is talking about. However, over here on the right-hand side, this is out of the American Wood Council's DCA 6, which is Design for Code Acceptance 6, which is the deck design. And it goes a little bit further in saying, look, this is what you have to do. Here is how you do it, right? What we're looking at, again, jumping back to the left-hand side, this is our attachment of our guard post to the rim joist of the deck. So we're talking about out at the end. The only way to attach this rim joist is to the end grain of these joists, which is strictly prohibited now. So the way to now attach that is by looking at what's being shown over here on the DCA 6 from American Wood Council. This is figure 26. This is showing hold downs being attached to that rim joist. Now this is transferring the load from that guardrail post to the rim joist directly into the joist of the deck, which exactly meets what the provisions we're asking for. Again, this installation was tested with the Virginia Tech testing facility, and they use this, and it absolutely does indeed meet the requirements. So this is out at the rim joist. This next section here, this next figure out of the commentary talks about we're talking about the side joist or the end joist on either side of the deck. Again, we want to prevent rotation of that joist. So now you have to transfer that load from that end joist to the next joist over. The code does a good job showing that you have to do it, but it doesn't necessarily dive quite deep enough in showing you how to achieve that. And figure 25 over here on the right-hand side also comes out of the DCA 6 from American Wood Council that shows how you can then provide some sort of a blocking in the interior bay. And now you have hold down that's attached to the post, that end joist, and then transferring that load again to that next joist on the interior. Again, 100% achieving the intent of the provision that I just went over. This is all new to the IRC, so this is extremely good information. Guardrails supported by top of the deck joist. This really comes down to proprietary products. And it says that they're allowed, right? But they just have to be installed with manufacturer's installation instructions, ensuring the transfer of the guard loads to the adjacent joists. The last one here, I believe is the last one. This is 507.10.2. This is wood post at the deck guard, where 4x4 posts or wood posts are being used. They shall not be notched at the connection to the supporting structure. I'm sure everybody on this call here today has seen this as an installation practice for deck guardrails. Now this is strictly prohibited, right? This 4x4 can no longer be notched. It must maintain its full 4x4. It can be installed either on the inside or the outside, However, notching it around is no longer prohibited. I'm sorry, this one here, plastic composites. Again, any regard to plastic composites outside of or outside of the scope of the IRC, and it really does point them to the installation of the per the manufacturer. So other guards, again, shall be in accordance with manufacturer's installation instructions or accepted engineered principles. Just to conclude this here, our exterior guards are going to be 4x4 posts with proper attachment per DCA 6-15 guidelines. Again, that DCA 6-15 is only a guideline. It provides really good details on how to help achieve what some of the provisions of the code are asking for. And the last final slide here that I have for today's presentation is our design, right? We started off with a 12-foot wide by 16-foot empty layout here, and we filled this in by working through the code provisions. So I truly believe that the code is now written in a way to help the design process for residential decks much more than it was back in 2009, 15, and 18. I believe that the steps that were taken are tremendous in helping ease the process of design that gives you a clear path. So just to conclude here, we are using 4x4 railing posts installed to prevent rotation that is typical around the board here.